Hello everyone, today we're going to be looking into Gemini, the AI generated code. I will be guiding Gemini in creating code in Rust. So we're going to be creating a trading app and we're going to start with market data adapter. Alright, so I guess Gemini can do Rust as we can see here. Let's give it some task. We're going to ask it to write a Hello World program first for us. All right, this looks like a good Hello World program. Now let's try to make it write as a market data adapter for some fake exchange. So we're going to start with JSON deserialization. So I'm going to ask now Gemini to generate a JSON deserialization code for this JSON I'm just typing in now. Guys, you cannot hear the original audio. I know I made a mistake. I didn't turn the microphone on when I was recording. This is why I have to do this voiceover now. I apologize for that, but it's also fun to do it. I'm learning new stuff, right? How to do voiceover in DaVinci. Okay, let's go back to the business. Okay, so now we have a data structure in JSON that contains market and price. Let's see what Gemini will generate. Okay, so we have some Rust code, right, that is deserializing this JSON. But there is something we don't like about it, right? We would like to use, some types for those price and market, right? The string here. It's not nice to have strings. Price should be double, and market should be something, normalized. So let's see what we will do next. Let's see, our next prompt is gonna be, can you use Serda instead? Okay, so that's what we do here. We ask it to use Serda because previous version was actually using object mapping. Okay, we don't want to have a main. We want to call it test market data. That's what we're going to do. And now we're going to tell it to be a test, right? So we're going to add a test macro on top of it. Okay, it's complaining something, but we're going to just tell it to do it. And it listened to us. We have a test before test market data. Perfect. So we have a test. We have our first test, we have data, and we deserialize some JSON. Let's see what we do next. Let's define a type, right? We want a type alias for price and for market, right? So that we use this type alias instead of strings. Now let's, We're gonna tell it what the name's gonna be, right? I think I came up with some abstract name, Gecko, right? I told it to be Gecko, Gecko market, and Gecko price. Okay, so we did it for the market, right? But we need to do it for the price as well. So let's do it for the price. So we're gonna ask Gemini to do the same now for the price. But look how smart Gemini is. It will understand what same means in this context. I just told it the name I want to use. Gecko price. And look at this. We have Gecko market and Gecko price. Everything is beautiful. And it's just nicely deserializing now. Right, now we're going to tell Gemini to change the type of the Gecko price to double float 64, right? So we want string to be converted into float 64. Let's see how this will work. see what my query was. Please assert with logic to make that happen. So I asked Gemini to just figure this thing out for me. And what it did, look, it did figure out, right? It created the gecko price. It's float 64 and serialized the serialized traits, implemented nicely for me. As you can see, I'm very happy with this result. Let's see what else can Gemini do for me. It looks like I'm very excited about this outcome from Google Gemini. Yeah, we're just telling that we implemented the serialized and the deserialized traits. We handle errors and everything with the conversions. So that makes us very, very happy, right? Okay, so now we need to treat the market a bit, because it's a string and we need to make it so that this string gets translated from one exchange to some normalized form. For example, ARBTC might be the symbol on the exchange, on our gecko, exchange, and then our normalized version can be AR/BTC, for example. So we want this to be automatically managed by the type of gecko market. I want to remind you that the gecko is just some fantasy exchange that if it exists, I don't know about it. I didn't check if it does or doesn't exist. I just came up with the random name. So it's just purely, abstract exchange. Okay, we're going to normalize it. We can see also that Grammarly is trying to fix my typos while I'm typing to Gemini. So, Grammarly is trying to make sure that I'm talking to Gemini in grammatically correct fashion, maybe in a polite fashion. Maybe I should ask Grammarly to restructure my query prompts so that they are maybe more formal or more polite. I wonder if Gemini would notice the difference. So yeah, we have our, gecko market now, and it's doing the serialize and the serialize in this new way. Okay, so what we don't like about this is that there is some incorrect creation of those symbols, So yeah, this code isn't really correct. Gemini did its best to figure out how to convert ARBTC to AR/BTC. But, it's not going to work for other symbols like ETH, BTC. So we need to do some changes here. We're going to introduce a global map that maps, one symbol to another. So we're going to do it now. I'm going to ask Gemini to create a global map. Yeah, I'm just trying to show you that this is just incorrect. Okay. That's ARBTC, that's what we get in the input, and we would like to get AR/BTC. So we're going to ask Gemini to create a map. I'm just explaining in a polite fashion to Gemini that we cannot be doing that, so that Gemini has a good understanding of what I'm trying to achieve, not only executing some random tasks. So I ask you to create a global mapping. See, with Gemini, you need to be like with a 5-year-old child. You need to just explain to it everything. And when you do, you get what you asked, I'm really feeling like, I'm raising a child here, child programmer. Okay. Teaching how to write code. All right, so we got our mapping, we have our serializer using the mapping, but our, it's actually the serializer looking the mapping, right? But the problem is that the serialization doesn't go the right way. Yeah, I wonder what I was saying there, because I seem very happy but unfortunately we don't have the original audio recorded, so I can only do the voiceover now. So I want to rename this normalized gecko market into just gecko market and get rid of the old one. And I want to introduce reverse map as well. So let's see what our next prompt will be. Oh, by the way, I could just fast forward this video and know what I'm going to write, but I think this is going to be more fun if I comment kind of live as I'm working on it. So I don't actually remember what I did, and I'm just commenting live, kind of. Okay, so I guess we were, what did we do? We just removed that old one, and now we can rename it. So I didn't want to confuse it. I didn't want to confuse Gemini, so I did it in two different prompts. First, I asked it to remove the old alias, and now I'm asking it to just rename the new alias. Right, so that's one thing. And the next thing, we shall introduce the reverse map, because this is incorrect. I'm pretty sure this is what I'm going to do next. Let's see. I feel like I'm telling that Gemini is helping me to type all this. You know, with these hands in the air, I'm trying to show that, you know, you'd have to be typing all this yourself. And with help of Gemini, you just say, hey, do me this. Can you do that? And all typing is, you know, done for you. So I feel like it would be amazing plugin for VI to just have, like, you know, instead of colon and VI command, some other type of colon, and, you know, you have Gemini doing things for you. So VI next gen uses Gemini to write your code, and you just tell it to those prompts like, hey, can you create me a struct? You know, so that would be like the better version of VI. Yes, we can probably have AI plugins for VS Code. I need to explore those. But I would like to see AI plugin for VI, for just raw VI. That would be cool. Okay, so what are we doing next? Yeah, we do implement serialize and deserialize for this structure. And then, okay, I'm saying how it works, right? So just look at the beauty of this design. So I just have this data structure data defined, and then it uses this type aliases, you know, and they know how to serialize themselves. So otherwise, I would have a lot of code that would be like parsing and serializing and stuff like this. And here I have this beauty of automated, you know, conversions. So I just have this JSON there, and because Serder knows what to do with this, it automatically, you know, deserializes into the types I like, and I eventually get price as float 64, and I get, you know, the market as normalized string instead of the original string. So the code becomes more, you know, the whole problem becomes more declarative. It's not so imperative, right? Okay, now we need to tackle this problem of reverse mapping, because, you know, we need to go the other way around now. We could just say split by slash and, you know, just remove the slash, but we're gonna just create a mapping because that is a safer option that will definitely work in all cases, maybe for all exchanges as well. So know that in every prompt I'm trying to tell Gemini, hey Gemini, you are a nice Gemini, I like you, you're my friend, you know, you did a good job, and, you know, I think we're missing something here. How about we just do this little change for me, you know? And Gemini is always like, hey Sonia, you are right, you know, let's do this. And this is so cool, because it's not like talking to a robot, it's more like talking to a good friend, you know? It's pretty cool. I love Gemini for that, for being so cool. Okay, so what do we have now? We have a reverse map as well. Okay, and now the reverse map, you see, it's creating the reverse map when we serialize, and that's not great, right? We just want it to be global, so we're just going to tell it to make it global. So you see how Gemini is doing the typing, and Gemini knows the libraries to include, it knows the function calls, it knows all those things that, you know, I will need to check the documentation, right? So I don't need to check documentation. I can work on a much higher level now. I can just tell it, oh, look, Gemini, the logic, the business logic is incorrect. You know, I can say, this is not correct business logic. We need to fix this business logic, as opposed to, oh my God, I need to go to documentation and see what was this call taking, or what's the name of the module, or, you know, these things can be done by AI, you know. So that's perfect use of AI, I'd say. Very, very helpful. Okay, so now we have reverse mapping. Great. And you can also see that it's using this map, right? Okay, so now we have a new thing. We have a structure called market mappings that contains two maps, reverse and forward, and we create a singleton, right, lazy static, of this structure. And now we can see that the structure is in arc mutex. The arc mutex is essentially, it could be just, it could create a type alias to something called shared resource. And I think I will be trying to explain it in a moment, that, you know, you need arc to share a resource between contexts, and you need mutex to share the resource between threads. So a shared resource stored in arc mutex is essentially a resource that you can share between threads, and that can be stored in multiple contexts. So let me explain it. So shared between threads mean only one thread can change it, right? So that's an obvious one. So that's why you need mutex. Why you need arc is because you can store this arc, you know, copy of this arc in multiple places, in multiple, you know, contexts, right? So that's why you would need arc to track reference count. And arc mutex is altogether this, you know, combination that creates a box within which you have shared resource. Okay, so mutex is not great. We're gonna change it in a moment to read-write lock from parking lot. I'm gonna be explaining in a moment, which you can't hear because there is no original audio. So I'm doing this voiceover for you. So what we'll do is we're gonna change this mutex, which will basically block all threads from accessing these market mappings, and only one thread will be accessing market mappings. So potentially multi-threaded code will become single-threaded code because all threads will be just waiting for this one thread. We want to change that because, you know, market mappings are mostly read-only. They changed only once. The write happens only on the program start. So there's absolutely no need to, you know, make all those threads wait, you know. So we're going to change it to read-write lock. Now, I'm going to be explaining here that read-write lock is like a room in a museum. So room in a museum, there is a glass box, and inside of the glass box there is this, you know, thing that we're looking at, right? So into that room with this glass box with the thing in it, we can invite viewers. We can invite many viewers, and they can all look into this glass box. They can see what is inside, but they cannot touch it, right? But the moment we want to change something in there, we want to change the content of the glass box, we need to tell all the viewers to leave the room because we don't trust those viewers. They could steal this valuable property, right? So we take the viewers out of the room, we close the room, and we let our trusted person go in and replace the content of the glass box, you know, and then one person goes in and opens the glass box and puts the new content in. So that's read-write lock. Let's wait for me to do it now. We're going to ask Gemini to just do it for us. And cool thing about it is there is references, so Gemini will automatically fix all those references in the code. Right, so we're going to use read-write lock from parking lot. What is parking lot? Parking lot is a library that implements, you know, lock protocol in a way that, you know, it's lightweight. It's, you know, it's probably using atomics. So this would be more like this read-write lock is probably more like atomic read-write lock, you know. So these market mappings, can be kind of accessed in a kind of atomic way. Well, it's atomic, but it's probably using some lightweight, atomic constructs underneath. So I didn't actually look into parking log implementation, so I cannot really tell you what it's doing, but I'm just making it up probably. But I suspect that this is what it is. It's just fast. It's just very fast. So this way we don't have to, if it's using atomics, we don't have to enter, this costly weight or anything in the operating system to lock the mutex or anything like that. So those threads that are trying to read those symbols, they will not be blocked by, by anything. They will just have very quick access to these mappings. Whenever we deserialize message coming from the exchange, we'll just very quickly access this hash map, and we will find a symbol, normalized version of a symbol. And whenever we want to send an order, we'll be able to very quickly find this exchange specific name of a symbol. Okay, now let's pretend that we will read all this from some database. So we're going to ask Gemini to generate some, more code that pretends that we're going to have a database and we're going to read that from database. All right, it looks like we have a load market mappings function now, and we have a singleton initialized by calling this function, right? But still, we don't have the database here yet, so that needs to be added. Okay, we're gonna just create a new class that will contain this market mappings and the database connection. Let's see how that will go. You can see that Gemini has created the config class, which contains the mappings, and they are loaded using load market mappings, but still it's not what we wanted, so let's continue. Let's make another request and ask Gemini to improve this. So this isn't exactly what I was thinking of, so let's ask Gemini to create a Gecko adapter class, which will have config in it and DB connection. Let's see where that will go. So as you see, I'm asking it to create a Gecko adapter object, which contains Gecko config. So yeah, I perhaps wasn't very explicit in what I was asking for, because what I'm getting here is still not what I wanted. I got a Gecko config still containing market mappings and Gecko adapter containing an arc to read the write log to Gecko config. Then this is not exactly what I was thinking about. So let's try to tell Gemini in some other way what we wanted. I must admit that I suspect at this moment I wasn't entirely sure what will be my design, so I was still browsing through the code and thinking what I'm gonna do and what will be my next prompt. So what I wanted was this market mappings to be in the adapter config to have some DB connection details like host and port and maybe list of symbols. And then this load market mappings to be called in some constructor of this adapter maybe. So let's see what we do next to achieve this kind of goal. Now I have noticed that this function doesn't take self, so I'm asking Gemini to add self parameter. I put the ampersand on the wrong side though, but Gemini was smart enough to figure this out. So I have noticed that the market mappings are still in the Gecko config, and I wanted them to be in the Gecko adapter. Also, I would like Gecko config to have host and port to the database, as well as a list of symbols to be then looked up in DB over this DB connection and populate the market mappings based on that. So let's see what we're going to ask Gemini. Yeah, so we're saying market mappings should be in Gecko adapter. I think I put a typo here. It should be market mapping should not be in Gecko config. But Gemini, I think, understood my idea. No, it didn't. Yeah, because I made a mistake, you know. So I think I need to fix this mistake. So you see, when I'm typing, I'm making so many mistakes. So Gemini has shown the previous code and new code now in this output, which was confusing that it's actually showing the previous code. It made Gecko config commented out because it figured out that we don't need it anymore. But the point was that we're actually going to add something there. So I'm going to tell it now to put host and port and the list of symbols in there. And interesting here is that I told it to use a list of strings called markets, but it automatically figured out what this markets is. So now Gecko adapter is missing the Gecko config. So I'm going to tell Gemini to add a Gecko config to Gecko adapter. Because the whole idea was that when we create this Gecko adapter, yeah, we wanted to create it from the config. Yeah, but I think putting it into Gecko adapter like this is not what we actually want. So we're going to change this again. And let's see if we can undo that. It looks like the undo doesn't work. So we will have to tell it to just, you know, move the things around. So our next prompt will be, you know, yeah, we want to see the whole code first, just to see what the code looks like. And now we're gonna ask Gemini to remove config from our adapter class. And we will ask now Gemini to create constructor of Gecko application that takes Gecko config, and the intention is that we will create this Gecko adapter using this Gecko config. Okay, but let's see what Gemini will create from that. So we have this load market mappings taking config, but it should also take DB connection. And DB connection is created at the same time as we're calling load market mappings. So the member DB connection of the adapter isn't known. So we need to, you know, solve this problem because we have catch 22, right? So we start by telling Gemini to add DB connection as parameter to load market mappings. We actually need load market mappings to be a global function because it doesn't actually fit into the Gecko application anymore. It takes the config, it takes the connection, so it doesn't need to be a member. So we have a problem here, right? The load market mappings is not using same DB connection as we created for DB connection member of Gecko adapter. We want it to be the same, so we're going to tell Gemini to change this code. Okay, so now we have one DB connection and we share it between the Gecko adapter DB connection member variable and load market mappings. We actually make a clone, but let's say if DB connection itself was clonable and internally contained some shared pointer, some arc to some actual resource, then cloning it would just increment reference. So maybe that's how this could work. Or alternatively, instead of DB connection, we could just be using arc of DB connection. So that's a design question. Let's see the whole code now. I really apologize that I didn't record the original audio. It sounds like I'm saying so many things there that are so funny, and it's not recorded. I'm so sad about it, but unfortunately, I hope I will make it up with this voiceover for you. It seems like I'm just happy that Gemini has generated me this whole parsing and serializing. We have this, Gecko price as well. Okay, I'm just checking if I have Rust installed. It does seem like I do. I do have cargo. That's great. We can now take this all generated code and try to compile it, see if it actually builds. So I opened this folder in my VS Code, and now I'm going to copy paste this code generated by Gemini. So there is an icon, copy to clipboard. Yes, and now I'm going to go here. I'm going to use *p. This is a VI command to paste from clipboard. It's *p. Okay, let's do cargo build. See what will break. Everything broke. everything is wrong, so code generated by Gemini doesn't build. Let's see why. It's missing some dependencies, right? So I guess we're gonna ask Gemini to generate us the dependencies. So for example, one of those messages, I'm gonna just paste and say, hey Gemini, I'm getting this error. How to fix that error? Right? Look at that. And it created the list of dependencies, and it not only fixed that one error, but it actually created the whole list of all dependencies we used. So we can just paste it into cargo toml. Bang. Okay, let's see how that goes. Okay, it's downloading all these dependencies and it's building, and bang, there is a problem. What the problem might be? So we're missing the reference to arc. Let's tell Gemini to generate us a reference. Here we go. std sync arc. We just need to add this. And yes, it was missing, as we can see. No, that's not how we paste. Paste. Okay, now we have arc. Let's see what happens next. It seems that DB connection doesn't implement clone trait, so we need to add that. Also, we don't want main to call test market data, so we just replace it with some print line. It seems like debug is not implemented for Gecko price and quantity, so we just ask Gemini to add those. We also want Gemini to add a derive clone to the DB connection. So we have more errors now. They are about the result. It says that SOK and SR is not, it can be used, right? But one thing I didn't notice here is that there is two different results, There is std fmt result being imported into this namespace, and it's confusing the compiler completely. So we'll have to fix that. I wasn't exactly sure what error I was getting and why because of this confusion with result. So I asked Gemini to find solution to the problem I was seeing in the error message, but I don't think that was actually the the solution. Then I tell it to change SOK and SR to direct cast to S being serializer, and then OK. So we're taking the OK from S as a serializer and so on. It automatically found that error should be taken the same way. So you can see that it automatically found that not only OK but also error is going to be taken this way. Now I'm not actually sure if this is needed, but it's no harm to, you know, make the scope clear for the compiler. And we tell it to change the D error for the same reason. So the statement for the same reason, Gemini actually understood what I meant by that. Now we still have errors because we didn't fix the actual reason of the issue. So the actual cause was that std_fmt result is conflicting with the result from core result. So, you know, we need to fix that. So I will ask Gemini now to reorder the code in such a way that things are defined before they are used. I thought this would be an issue, so this is why I'm asking Gemini to do this refactoring. So now I just asked Gemini to put gecko market, gecko price, gecko quantity at the top of this code. We also want to define the data straight after gecko market, gecko price, and gecko quantity, and we probably want to rename it to gecko data. It looks like Gemini has made up some port number for my DB connection, as well as the markets. It was AR BTC, and it created ETH BTC out of nowhere. That's pretty cool that it used some creativity here on its own. It really feels like a peer programming with Gemini, because I'm just telling it, hey, let's do this, and Gemini is just, okay, I'll do this, and how about I'll do also this? It's pretty cool. And let's see if that compiles. I'm pretty sure it won't, because we still didn't fix the result problem. And here we go. There's an error. Print line is a macro, Sonia. You need to put an exclamation mark there. Okay. And I think this is the error message that made me think that, okay, I think I know where the problem is. Right now I'm inspecting the code to realize that this result is not the right one. It looks like Sonia finally found the answer to this question. Hooray! It took her a moment, but yeah, she found it. Now, yeah, the question mark is not needed there. We're just returning the result from serialized str, which is matching the result type. Yeah, std fmt result. And there will be more changes required, so we're going to ask Gemini to do this for us. So it seems like we removed the import of result, but we also removed the import of formatter and debug, and we need to bring that back in. So we also need the formatter, right? Okay, so now we're just having last thing, test market data. We shouldn't be calling that in main. Just remove that and see what happens. Bang! It finished. It's complete. Compiles. The code finally compiles. The code that we produced together with Gemini is now compiling. So now we're going to add quantity to the market data, and perhaps later we're going to add side as well. It seems that Gemini thought quantity will be float 64, but we don't want it to be float 64, we want it to be Gecko quantity type alias to float 64 with all the Serde magic. So we got type alias to string, and we don't like that. We would like it to be type alias to F64 and parse a string, which is decimal string, into float 64. And now let's add the side, but we're gonna make it an enum gecko side, which has bid and ask. Alright, so we have Gecko side that has ask and bid. Looks good. But now we would like them to serialize from specific strings. And here I have changed my mind. I wanted those different strings. Just look at the tone of my conversation. It's Gemini. I'm trying to be polite. I don't want to offend Gemini. Let's see the whole code again, so I can try it out in VS Code. I'm gonna be a little bit ambiguous here. I'm just gonna say, let's just use ask instead of sell and bid instead of buy. And Gemini has to figure out what I mean by that. And it was quite successful in doing so, as we can see, which is pretty cool. This main keeps coming back. Let's tell Gemini to get rid of that. So I just say to Gemini, hey, I want the main function that just says hello because I don't want it to be calling test market data. So now we have a code straight from Gemini that compiles, no problem. So I think I'm basically saying here how cool is that Gemini has written the code for me, and I was just writing prompts to correct Gemini, to guide Gemini, to give me the code I wanted. The problem with the result was that it confused me and I didn't really know what's going on. So yeah, that was an interesting one. But in general, yeah, we have a code that actually will work properly. And because we're using this type aliases, you know, with Serda implementation for them, we can just literally, you know, parse JSON strings without any additional, you know, function calls. It's all automagical, which is nice, and it's all compile time static because Rust trades the compile time, so it knows actually what it wants to deserialize. It's like C++ templates, right? So it will know that it's deserializing this in this field, and so on. I think I've noticed that the field is called size instead of side. And I asked Gemini to rename it, but I don't think it worked. Let's add some assertions to our test. And here we are. Gemini has added the assertions. I think I'm just saying that Rust is a very good language for Gemini to generate code because it's functional and the result of one operation is the input to other and so on. Like it all makes sense. It's mathematically provable. So I guess, well, I don't know. It's Gemini compatible. Like Rust is a language that Gemini can understand in some way. All right. Since Rust is so similar to Scala, let's see what Gemini will do if I ask it to make it a Scala version. That's fun, right? We're just turning Rust code into Scala, and this is what happens. We've got Scala code that looks like Rust, it's just using Scala syntax. We've got all the types defined in the same way. We use the case class, we use object, and yeah, this is all like almost the same code as we can see, right? So deserialization is basically done by implementing this from string. So, and then the toString for the quantity and price. I'm just noticing that in Scala and Rust, the match statement is just a little bit reversed. So in Rust you have the value after the match, and in Scala you have it before the match. In Scala you have a case keyword, in Rust you don't have a case keyword. Now one more thing here is in Scala you shouldn't be using option for errors. So I'm gonna ask Gemini to fix that, to use either instead. And here we go, we have either. So left is error, right is the value. And Gemini knows that convention. Pretty cool, no? We have a Scala code generated from previously generated Rust code. So we asked Gemini to produce Rust code following our guidance, and then we asked it to turn it into Scala. And it's all good. I haven't tested it, but to my eye it looks correct. We'll need to test it. So in Scala, the constructor can be defined like in an implicit way by just saying in round bracket here the parameters for construction and the names of the variables, and then the class itself will have fields with the same names, you know. So this is pretty cool that you don't have to actually define the whole body of the class. You can just do it that way, and it's a shortcut. Now, the reason we use case class here is because we want to use automatic deserialization, so that uses, you know, some sort of enumeration type of classes, I guess. So I actually don't know why does it need to be a case class. It can be just class, but I suspect this the code that we have here in the parse gecko data, it requires this gecko data to be case class. So in general, case classes in Scala are the same thing as enum in in Rust. Although, as you remember, we didn't have to implement enum for all the types that we deserialize, right? We just implemented serialize and deserialize traits in Rust. And here it sounds like case class is the way to do it. Also, I see that in Scala you have this strip margin thing. So if you put a pipe character in front of every line, I think the margin before the pipe will be removed together with that pipe from the text. It's not needed, I guess. This JSON is totally fine with the indentation, whatever we want it to be. So we don't need to strip the margin, but this is actually pretty cool to know that you can do that. And guess what? These are some pretty cool features that I just learned about Scala from Gemini, you know. Gemini is telling me things that I actually didn't know before. Pretty cool, no? So I think I'm explaining now that in Scala there is no need for curly brackets. Their function is simply to create a set of statements instead of just one statement. So when you do a definition of a method, function, or a symbol of any kind, you just use equals character, and you can just say equals 5, and that's it. That's perfect. The one and only reason we use curly brackets is to create a block of statements, and the value of this is gonna be the last statement, same as in Rust. It's just in Rust curly brackets have semantic meaning, and here they are totally optional. And I think much requires curly brackets actually. For much, I think this is part of the syntax, but for functions this is totally optional. You can just say equals 5, that's it. So to summarize, in my opinion, in my heart, Scala is way superior to Rust in a way of like it's a functional programming language, and both are. Rust is compile time. Everything happens in Rust in compile time. But you need to remember that Scala runs on JRE, on it uses JIT, and in Java everything is compile time as well, because you see, at runtime, things compile, and when they compile, they're compiled, and everything that was there is now compiled. So, it's kind of a runtime which becomes compiled, compiled at runtime. We know from some tests, performance tests, that, for example, Graal JVM can be very, very fast. So, argument that Java is slow is, I don't know. I'm not going to argue here. I'm just going to say that I love Scala a lot, and Rust is amazing, but I love Scala a lot. It's more mature, it's more well-defined. It has this type erasure problem, but yeah, it is what it is. There is work around it, right? We don't like workarounds, but yeah, Scala has this problem. And it's kind of difficult to understand sometimes the code that tries to overcome the type erasure. But yeah, just need to get used to it, I guess. Rust has a problem of lifetimes. So if you use references, you have to remember that, you can only refer to the objects that live not shorter than your scope. Objects that you're referring to have to live at least as long as your scope while you're referring to them. And if you cannot guarantee that in a mathematically provable way, then you have to resort to things like unsafe, and that becomes, that just defeats the purpose, right? Because you start using unsafe. In Scala, you don't bother with that. You just have everything being, JRE objects, and compiler will optimize it whichever way it wants. So you are free to not bother with lifetimes, You just focus on the actual logic, what you want to achieve. Both programming languages, have their advantages and disadvantages. Yeah, I don't know. Both are cool. Both are super cool languages. So here I just asked Gemini to use tolerance for floating point comparisons, because we know that equality comparisons for floating points isn't going to work very well. The representation of a number 0, decimal 0012, in binary, when converted to decimal, may give some number like 0.001199999, for example, and that's gonna fail assertion, right? So we want those tolerance checks. I'm gonna put this now into Gecko application Scala folder and open in VS Code and see how this code looks in VS Code. Thank you for watching and stay tuned for more videos.